Oh, what's in the box?
Well, I'm on a mission to capture an elusive ingredient to take my amateur pyrotechnics to the next level. I'm hunting my white whale, awesome senko hanabi fireworks. Now, you probably don't know what senko hanabi is yet, but you do know what a mixture is. And in chemistry, mixtures are defined as physical combinations of several different substances, each with unique chemical and physical properties. And that's what makes a mixture awesome. All those substances retain their unique properties in the mix. You know, like when you eat a sandwich and you taste everything in there.
It's like there's a party in my mouth and everyone's invited.
I remember that being about a sandwich.
It's like a party in my mouth and everyone's throwing up.
Well played, Futurama. Great callback.
Great sandwich.
Getting back on topic, a mixture is greater than the sum of its parts. Black powder, like the kind used in fireworks, like this enchanting handheld senko hanabi, is a mixture. Inside this tightly wound paper casing is less than 1/10 of a gram of specialized black powder. In fact, you can really think of mixtures like putting a crew together.
Hello, Peter. We're not joining your team.
I'm putting together a team.
We're in.
So disclaimer time, if you're not trained in pyrotechnics or lab safety, fireworks are a great way to injure yourself and others. So be careful. And don't get too hung up on the percentages I'm about to share. I'm keeping this pretty general, and there are probably better ratios out there for black powder, but nonetheless, here's our crew.
Uh-oh. I know that look.
I'm putting together a team.
Then I'm in.
The pyro, the hothead, the loose cannon, aka lunar caustic, aka potassium nitrate, mayhem incarnate. In the business, this is called a chemical oxidizer. Oxidizers can be very dangerous. The black powder in my senko hanabi is about 50 to 60% potassium nitrate. Think of a model rocket engine. Without potassium nitrate, the reaction would probably sputter out as it gasped to find oxygen from the outside environment. The topic of oxidizers is probably worth its own standalone video, and if you like the idea of that, please let me know in the comments below. Remember, I don't have sponsors, just awesome subscribers. Like you. Every crew needs someone to pull the team together. Weighing in at about 30% is the Danny Ocean of our mixture, sulfur. Now that's about 3 times the amount present in many pyrotechnics, but that's because sulfur is pulling double duty here. Not only does it play a role in gas production, but it is critical to the production of the telltale dross ball, the pulsing chemical reactor where all the magic of senko hanabi happens. You can really think of sulfur like the marshmallow in a crispy pyrotechnic Rice Krispie treat. Without it, the whole thing just falls apart. Every crew needs muscle, that dependable workhorse, like a B.A. Baracus or Trucula.
Hey, Trucula! You son of a... I mean...
Clocking in at about 10% of this black powder, charcoal provides most of the fuel for the senko hanabi, especially in the early stages. Charcoal has played a pivotal role in the development of human civilization, from applications as varied as household cooking to smelting iron ore. Business is booming, with global charcoal production nearly doubling since 2000. In fact, estimates put the global market value of charcoal well over $1.5 billion. Charcoal burns hot, typically twice as hot as the temperature of the source wood. Charcoal fires can reach temperatures exceeding 1,000 degrees Celsius, 2,000 degrees Fahrenheit. You might think you can just burn wood to get charcoal, but it's not that simple. The production of charcoal is a type of pyrolysis, a chemical degradation at high temperatures in the absence of oxygen. More specifically, charcoal is created by a type of pyrolysis called destructive distillation. Now, what's interesting about destructive distillation is that first word, destructive. You separate it by destroying some of the original substance. Wood is charred into charcoal, undergoing chemical changes in the process. Now, burning charcoal ideally produces only heat and carbon dioxide, so technically burning charcoal is probably healthier than burning wood, but let's not forget the volatiles that you cooked off during the preparatory pyrolysis. So overall, I'm not sure burning charcoal is better for the environment. If anybody knows of any comparative pollution study of cradle to grave use of charcoal versus wood, then please let me know in the comments. If you want to learn more about charcoal, allow me to plug Nighthawk in Light's channel. He's got great videos on charcoal, senko hanabi, and all kind of other cool stuff. Great channel, great guy.
Great sandwich.
But we've only got 3 members of our team here. I think we still need one more.
Think we need one more? You think we need one more? All right, we'll get one more.
And that's why I needed that box.
Oh, what's in the box?
See, 2 Brad Pitt references.
Right? Brad Pitt. 7. Nothing. Yeah, I'm the jerk.
Every crew has a secret weapon, the behind-the-scenes genius, a Snake Eyes, a Robin Masters, or a Bonnie Barstow.
I wonder if there's a real woman under those overalls, or just a robot.
Under the overall, she's 168 centimeters tall, 54 kilos in weight.
Ooh, well, that was more sexist than I remember. I don't even think I can give him points for using the metric system.
What's in the box?
Get into it, Brad. Relax. It's soot. The answer's soot. Soot? Huh. What is it good for? Absolutely one thing. Say it again. Huh. Senko hanabi. So there isn't much soot in here, just a couple thousandths of a gram per senko hanabi, and yet it plays an important role in the branching and sparking crucial to a dazzling display. Soot, like charcoal, is formed through pyrolysis, the incomplete combustion of hydrocarbons. But while charcoal is formed from the destructive distillation of wood, soot is formed from the incomplete combustion of hydrocarbons already in the gas phase. That means we're getting much smaller particles, 1 or 2 orders of magnitude smaller than the ones found in our finely ground airflow. If you've ever seen an 18-wheeler belching out black clouds of smoke, then you've seen soot. Soot is nasty stuff. It's a known carcinogen. The soot from diesel emissions has been estimated to account for up to a quarter of all hazardous fine air particulates. Soot is a real health hazard, and it's one of the reasons I try to mask up when I'm working with it. This is also the main reason I wanted to find a new way to harvest soot. My old technique, holding a piece of metal over a flame, left much to be desired. Most of the smoke just rolled past, meaning more to pollute and more to inhale. And then I saw a video on traditional senko hanabi manufacturing, link in the doobly-doo, where they used a cloth chamber to collect soot. A lot of it. I knew I had to try this myself. I had no way of knowing what the fabric was, so I just ordered some flame-resistant fabric, and I made 4 2x3 panels. And I hoped that I could build something big enough to house the fire without, lighting the whole thing up on my driveway like some East Coast Burning Man knockoff. My miter saw, staple gun, and underwhelming upholstery skills cobbled together something passable. And to keep things as simple as possible, I just held the 4 panels in place with some tightened twine, and the final panel would sit snugly on top. The key ingredient of good soot, or shoin as it's called in Japan, seems to be good pine sap. So I've tried burning turpentine, which works well, but it burns hot and I feel like it's a little dangerous. I've crafted my own artesian small batch pine resin straw pellets, which smelled wonderful, but were a lot of work for a questionable bump in quality. In the end, I settled on burning fat wood. These are pieces of pine wood that are naturally high or fat in flammable pine resin, which is why it is typically sold as a fire starter. Now, a true craftsman would harvest their own fat wood. People like me, we just order it online. But I'm going to add a harvest fat wood to my bucket list right now. Oh, well, I guess I can cross off a spoof an Edwin Starr song. So I set up the box on 2x4s to get a little bit more airflow since the fireproof fabric wasn't very breathable. And I did get a successful proof of concept on the first run. The cage did not erupt into flames, and I even managed to get a little buildup on the inside. So I ran it 3 more times to see what I could harvest, and I didn't get much. For all that work, I probably got about a ½ gram of soot. But it looked like it was kind of seasoning the fabric. The soot was filling up the imperfections, kind of like butter filling up the nooks and crannies of an English muffin.
They toast up crunchy like no other, with nooks and crannies to hold the butter. Sure are funny, all bright and sunny, Thomas's English muffins.
You know what? Reference obscure 80s English muffin commercial. I'm really making some progress today. So I put the box back together and did another 3 runs, and the soot was definitely piling on there thicker. So I went ahead and committed to another 6 runs, and boy, the smoke box did not disappoint. Now, my recipe needs tweaking and my wrapping skills leave much to be desired, but this looks like good soot, and now I have a reliable method to try to capture more in the future. So as I packed up my collection of blackened panels, I couldn't help but be reminded of a story I'd once heard about the origin of black belts in martial arts. The story says that everyone started with a clean belt, like the virgin cloth of my smoke chamber. But no one ever washed the belts, so those students with the most practice had the dirtiest belts. You could, at a glance, judge a practitioner's skill level just by looking at the filth of their belt. And if that's the case, well, it's time to get a little dirtier here. Thanks for being part of my crew today. I really appreciate you spending some time with me. I hope you learned something from this, whether it be about senko hanabi, mixtures, the 80s, martial arts. It's all good. Have a great day.